Way back in time, long before you were born, even before dinosaurs roamed, there was no Earth. There wasn't even a sun shining in our sky. Instead, imagine a gigantic cloud floating in the vast, dark emptiness of space. This cloud was enormous, far bigger than anything we can easily picture. It was mostly made of gas, like hydrogen and helium, the lightest stuff in the universe, but it also held tiny, tiny specks of dust. These dust grains were like superfine cosmic powder, holding all the raw materials needed to build stars and planets, including our very own homeworld. This was the starting point, a cold, dark, and patient nursery for future worlds. Then something disturbed this giant sleepy cloud. Maybe a star nearby exploded, sending a powerful shockwave through space. Or perhaps another cloud drifted too close and their gravities started to pull on each other. Whatever the cause, parts of this huge cloud began to fall in on themselves. Gravity, that invisible force that keeps your feet on the ground, started to pull the gas and dust closer and closer together. As the cloud squeezed itself, the center started to get denser and hotter. Think of it like a crowd of people all trying to get into a small room. It gets packed and warm very quickly. This was the very first step towards making a star. As all this material rushed inwards, the cloud didn't just collapse straight down, it began to spin. Imagine an ice skater pulling their arms in. They spin faster and faster. The same thing happened with our cosmic cloud. This spinning motion was super important. It prevented everything from just crashing into one giant blob in the middle. Instead, the spinning action caused the collapsing cloud to flatten out. It transformed from a big puffy ball into a wide, flat spinning disk, kind of like a giant cosmic pizza or a spinning record. This disk is called a protoplanetary disk, which is a fancy way of saying a disk where planets are about to be born. At the very center of this spinning, flattening disk, things got incredibly hot and incredibly dense, so much material packed together that a new star began to light up. This star was our sun. It wasn't quite the bright, steady sun we know today, but it was on its way. Around this young, fiery sun, the rest of the disk continued to swirl. This disk was still full of gas and dust, the leftovers from the sun's birth. And it was in this swirling, dusty disk that the real magic of planet formation was about to begin. All the future planets, including Earth, were just tiny specks at this point. So we have our young sun blazing away at the center of a giant spinning disk of gas and dust. Further out in this disk, away from the intense heat of the baby sun, it was much cooler. Here, those tiny specks of dust we talked about earlier started to play a crucial role. These weren't just any dust particles, they were made of different things. Some were rocky, some were metallic, and in the colder outer parts of the disk, some were even icy. Think of them as the universe's tiniest building blocks, smaller than grains of sand you find on a beach. These little bits were floating around, minding their own business in the swirling disk, but they didn't stay separate for long. These tiny dust grains began to stick together. How? Well, maybe it was a bit like how dust bunnies form under your bed, with tiny fibers clinging to each other, or perhaps static electricity played a part, like when a balloon sticks to your hair after you rub it. Slowly but surely, one dust grain would bump into another and stick. Then that slightly bigger clump would attract another grain, and then another. It was a very slow process, happening over millions and millions of years. Little by little, these specks grew into slightly larger particles, then into small pebbles. These pebbles continued to grow. As they got bigger, their gravity, even though it was tiny, started to help pull in more dust and smaller pebbles. They grew from the size of marbles to the size of rocks, and then to the size of boulders. Eventually, some of these clumps of rock and ice grew to be quite large, maybe a few miles or even tens of miles across. Scientists call these early small bodies planetesimals. The word planetesimal basically means tiny planet or piece of a planet. They were like the first rough drafts of planets, not yet big enough to be called true planets, but definitely on their way. Imagine millions, perhaps even billions of these planetesimals orbiting the young sun within the protoplanetary disk. It would have looked like a vast cosmic swarm, a blizzard of rocks and ice chunks, all moving around the sun in their own paths. Each planetesimal was a potential building block, a seed from which a larger world could grow. The solar system was like a giant construction yard, and these planetesimals were the bricks and stones scattered everywhere, waiting to be assembled into something much grander. The stage was set for the next more dramatic phase of planet formation, where these small bodies would start to come together in a big way. The early solar system, with all those planetesimals swirling around, was not a calm and peaceful place. It was more like a giant, chaotic construction zone in space. Imagine millions of rocky and icy bodies, from small pebbles to objects miles wide, all orbiting the young sun. Their paths weren't always neat and tidy. They crisscrossed and intersected. There were no traffic lights or stop signs out there in the protoplanetary disk. This meant that collisions were incredibly common. It was a period of intense activity, a cosmic demolition derby where things were constantly bumping into each other. This was how planets started to take shape. When these planetesimals crashed into each other, a few different things could happen. If the collision was relatively gentle and slow, the two planetesimals might merge together, sticking to form an even larger body. Gravity played a big role here. As a planetesimal grew bigger, its gravitational pull became stronger, making it better at attracting and holding onto other, smaller planetesimals that came near. So the bigger ones tended to grow bigger, faster. It was a bit like a snowball rolling downhill, picking up more snow and growing larger as it goes. This process of gradual accumulation is called accretion. However, not all collisions were gentle. Many were incredibly violent, especially if the planetesimals were moving very fast when they hit. In these high-speed crashes, the planetesimals could shatter each other into many smaller pieces, creating even more dust and debris. So it wasn't just a simple story of everything sticking together, there was a lot of breaking apart too. It was a constant battle between construction and destruction, but over vast stretches of time, the building up process won out. The larger bodies that survived these energetic collisions continued to sweep up material in their orbital paths. Through this messy, energetic process of countless collisions and mergers, a few planetesimals grew much larger than the others. These became the winners in their particular zones of the solar system. Their gravity became strong enough to dominate their surroundings, pulling in most of the remaining planetesimals' dust and gas in their vicinity. They gradually cleared out their orbits like cosmic vacuum cleaners. These much larger bodies are called protoplanets, almost planets. Earth itself started out this way, as a growing protoplanet formed from the debris and countless impacts of smaller planetesimals in its region of the solar system. It was a tough neighborhood to grow up in. So after all that cosmic crashing and bashing, our planet Earth was finally formed. It was one of the lucky protoplanets that grew big and strong, but the early Earth was nothing like the beautiful blue and green world we know today. It was an incredibly hot and hostile place. All those collisions from planetesimals hitting it generated a tremendous amount of heat. Imagine things smashing together at high speeds. They get hot. Also, radioactive materials trapped inside the young Earth were decaying, releasing even more heat from within. Our planet was essentially a giant glowing ball of molten rock and metal, a seething fiery sphere. Over many millions of years, this super-hot baby Earth began to cool down ever so slowly. As it cooled from the outside in, a thin, rocky crust started to form on its surface, like the skin on cooling pudding. But this crust wasn't stable yet. The inside of the Earth was still incredibly hot and active. This internal heat needed to escape, and it did so through massive volcanic eruptions. Volcanoes were everywhere on the early Earth, constantly spewing out molten lava, ash, and huge clouds of gases. These gases, like water vapor, carbon dioxide, and nitrogen, began to create Earth's very first atmosphere, very different from the air we breathe today. One of the most important gases released by these ancient volcanoes was water vapor, which is just water in gas form. As Earth continued to cool, a point was reached where the atmosphere became cool enough for this water vapor to condense. This means it turned from a gas back into liquid water, and then it began to rain. It didn't just rain for an afternoon, it rained for thousands, perhaps even millions of years. This was a downpour of epic proportions, a planet-wide deluge. This relentless rain slowly filled up the low-lying areas of Earth's cooling crust, forming the very first oceans. Imagine a hot volcanic landscape gradually being covered by vast steaming seas. And so, from a chaotic beginning of colliding space rocks and dust, our planet Earth began to take on a more familiar form. The fiery molten ball transformed. It developed a solid crust, a gassy atmosphere, and vast oceans of liquid water. It was a long and dramatic journey from a humble collection of cosmic dust in a giant cloud to colliding planetesimals to the young, hot Earth and finally to a cooling world where life would eventually find a way to begin. It reminds us that even the grandest things in the universe, like our own planet, can have very small and messy beginnings. What an amazing cosmic story.